Hey everybody, this is my attempt 2 at recording your class today. So sorry we couldn't have class today. So all I wanted to do today in class was finish these 4 multiplication problems that we have on page 201. So the first problem says that we want to take 4/5 times 3.5. So that means we want 4/5 of 3.5. So I've already drawn out what 3.5 looks like. So we want to take 4/5 of the 3.5. So that means I want to take 4/5 of this one, and 4/5 of this one, and 4/5 of this one, and then 4/5 of this piece. So if we split these into fifths, so we take 4/5 of the first one, and 4/5 of the second one, and then 4/5 of the next one, and then 4/5 of this half. So split it into 5 pieces and take 4 of them. Okay, so to get our answer, normally we just count the number of pieces that we have and then say how many pieces it takes to make the whole. But right now for this one, we have a problem because we have fifths, 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 and then this last half, if we actually cut the whole rectangle into equal size pieces, you'll see these are tenths. So we can't add fifths and tenths. So we need to make them the same size pieces. So I want to chop the other 3 in half so that they make tenths. So then if we count our pieces, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we have 28, and then it takes 10 of those pieces to make the whole. So 4/5 times 3.5 should be 28 tenths. And we can check this by doing the standard algorithm. So if 4/5 times 3.5, we make the mixed number into an improper fraction. So 2 times 3 is 6, plus 1 more is 7. So that's 7 halves. So then you can see 4 times 7 is 28, and 5 times 2 is 10. So we're supposed to get 28 tenths, and that's what we got. So I'm not going to reduce any of these. You totally can if you want to, but since I'm making a video, I want to save a little bit of time and not reduce them. But you can if you want. So the next one, 3 1/3 times 6/7. So that means I want to make 3 1/3 groups of 6/7. So I'm going to have my first group of 6/7, my second group of 6/7, my third group of 6/7, and then we need a third of a 6/7. So I've, again, already drawn out what 6/7 might look like. So if we need 3 groups of 6/7, so we're going to take this full 6/7 here in my first group, my full 6/7 here in my second group, a full 6/7 here in my third group, and then I need a third of a 6/7. So if you just focus on the 6/7, you should see that you have 6 pieces right here. So if I want a third of 6 pieces, how many is that going to be? So that should be 2 pieces. So these 2 make a third, these 2 make a third, and these 2 make a third. So 2 out of the 6 should be a third. So you're left with that. So then, again, we count pieces to get our answer. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pieces this time. And it takes 7 of those pieces to make a full rectangle. So answer should be 27ths. And again, we can check this with the standard algorithm. So 3 1/3 times 6/7. would be 3 times 3, so 9 plus 1 is 10/3, times 6/7 would be 60 21sts. So 60 21sts will reduce down to be 27ths. So 60 divided by 3 makes 20, 21 divided by 3 makes 7. Okay, so we do have an equivalent answer. So that one works. The next one, so 2 1/4 times 3 1/3. So that means we need 2 1/4 groups of 3 1/3. So again, I've already drawn out what 3 1/3 will look like. So we need one full group of 3 1/3, a second full group of 3 1/3, and then 1/4 of another 3 1/3. So we need, again, one full group of 3 1/3. So we're taking all of that. We need a second full group of 3 1/3, which is that much. Then we need a fourth of 3 1/3. So we're going to do the strategy like we just did up here on this one, where we needed 4/5 of each of these pieces. So we did 4/5 here, 4/5 here, 4/5 here, 4/5 here. So it's going to work the same way. We need a fourth and a fourth and a fourth and a fourth. Fourth of each piece. So that means I am going to split these into fourths. So I'm going to take 1/4 of my first one, and then 1/4 of my second one, and then 1/4 of my third one, and then 1/4 of the 1/3. So chop that into 4 pieces, and we have this tiny little bit right there. Okay, so to get our answer, we would need to count pieces, and we have a small problem again, because we have whole things, we have a third, a third, a fourth, a fourth, a fourth, and then this one, if we cut the full rectangle into same size pieces, you'll see that's 12ths. So I can't really right now add thirds and fourths and 12ths. I need them to be same size pieces. So I'm going to have to cut the thirds into fourths. And then I'm going to cut the fourths into thirds so that I have 12ths. All right, so to get our answer, we're going to do a little bit of math right here. So we have 6 whole rectangles. So I'm going to write 6. And then we also have all of these like little bits of 12ths. So if we count how many 12ths we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 of them. And it takes 12 of them to make one full rectangle. So that should be 18 12ths. So what does that reduce down to be? So 18 12ths would be 1 6/12, which would be the same thing as 1 1/2. So we have 6 plus 1 1/2. So our answer should be 7 1/2. So we have 7 1/2 total. 2 1/4 times 3 1/3. And let's see what the standard algorithm looks like for this one. So that would be 9/4, and then 3 times 3 is 9 plus 1 is 10/3. So that's going to be 90 12ths. So let's see. So how many times does 12 go into 90? That should be 7 times. If that would be 84. So then if that's 84, then you would have 6 left over. So 7 6/12. So yes, 7 1/2 reduces down to be. So that one checks out. And then finally, we have 2 3/5 times 5 5/6. So we need 2 3/5 groups of 5 5/6. So again, I've already drawn out what 5 5/6 will look like. So we need 2 full groups and then 3/5 of another group. So we are going to take 1 full group of 5 5/6, and then we're taking a second full group of 5 5/6. And then we need 3/5 of the remaining 5 5/6. So what we've done before was we split this into fifths, 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 and then these into fifths, and taken 3 of them from each one. However, what happens to be nice about this problem, if you look at the number of whole rectangles you already have 5 whole rectangles. So 3/5 would be 3 of those 5 rectangles. So we actually don't have to divide anything up. And then the same thing is true over here. 5/6, we had 5 shaded in pieces. So 3/5 would be 3 of those pieces. Okay. So then if we go to get the answer, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 rectangles. And then we have the sixths hanging out over here. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of those pieces. And it takes 6 of them to make a whole rectangle. So we have 13 whole and then 13 sixths in little pieces. So if we reduce that, 13 sixths would be 2 1/6. So our answer should be 15 1/6. 15 1/6. And if we check with the standard algorithm to make sure we did this one right, let's see, that would be 13 fifths times 35 sixths. So that should come out to be 455 thirtieths. So then if you reduce that, how many times does 30 go into 455? That should be 15. And let's see, that should make 450. So then you would be left with 5 thirtieths, which reduces down to be a sixth. Okay.